Well, hi everyone, and I hope that you had a great reading week, or at least you're going into reading week. We're in reading week here, and as promised, I am making the recording of our session 6, Deductive Reasoning and Categorical Logic. And so I hope that this will be helpful to you, and that you will be able to follow along. So when we think about categorical logic, we of course highlight the fact that this is a form of logic whose focus is categorical statements which make assertions about categories or classes of things. So that's really important. What you want to notice here is that it's a form of logic, and that it makes assertions about categories or classes of things. And so you can either have the predicate when we study the relationships between components known as the subject and predicate of a statement. And we use diagrams. We actually use Venn diagrams and calculation rules, and we'll look at these as we progress under this idea of categorical logic. I'm just trying to, there we go, move it forward. So in categorical reasoning, the statements or claims of interest are categorical statements. They say how certain classes of things are or are not included in other classes of things. So we have these examples in a categorical statement. All cows are vegetarians. So all cows are part of the class of vegetarians. No gardeners are plumbers. So that's asserting a negative, that no gardeners form part of the class of plumbers. And then, of course, this idea that some business people are cheats. And so we're asserting here that some of the category or some of the predicate of business people are part of the category we know as cheats. The words in categorical statements that name classes or categories of things are called terms. So we know that each categorical statement has both a subject term and a predicate term. So you need a subject and a predicate. For example, all cats are carnivores. All cats are carnivores. The subject term, of course, that we see here is cats. So the subject of this categorical statement is cats. The predicate term, of course, is carnivores. All cats are carnivores. And so we're saying that the class of cats is included within the class of carnivores. So cats are included in this class of carnivores. Now, this is really helpful to us, and you want to know this for your exam. You want to be sure that you have this nailed down for your exam. But there are 4 standard forms of categorical statements, and I like to remember it in terms of our vowels, A, E, I, O, and of course U, except there's no U here. But the A statement is a universal affirmative. So when you think of A, think of a universal affirmative, okay? All S or P, all cats are carnivores. All cats are carnivores. So that's the A statement, all SRP, all cats are carnivores. And then no SRP. And so now you move to the E statement, which is the universal negative. So the A statement is the universal affirmative, all cats are carnivores. And the E statement is the universal negative, no cats are carnivores. And then we have the I statements. Remember AEI, and you see here the I statement. This is a particular affirmative. In other words, some cats are carnivores. Some cats are carnivores. That's the I statement. And then the O statement, which is a particular negative. Some cats are not carnivores. Some cats are not carnivores. So A, E, I, O. A, universal affirmative. E, universal negative. I, particular affirmative. And O, particular negative. Very helpful to know in categorical logic, and very important to remember in categorical logic. All right. So moving on. Sorry, I was just trying to adjust the screen here. Statements and classes. The terms in these statements about cats are single words, just nouns naming a class. But, and this is important to note, subject and predicate terms can also consist of noun phrases and pronouns. Example, cats that live outdoors, or animals with fur. So statements like this are also categorical. For instance, some animals with fur shed in the house. Now, again, I want you to think about, is this an A, an E, an I, or an O? A, E, I, O. Is this an A, universal affirmative, E, universal negative, I, particular affirmative, or O, particular negative statement? Of course, we would say it's an I. Some animals with fur shed in the house. Subject and predicate terms can only be nouns, pronouns, and noun phrases, i.e. carnivorous cannot be used because it's an adjective. So very, very important to notice that subject and predicate terms can only be nouns. Categorical statements have four parts. We've seen the subject term, the predicate term, and then the copula, which is a linking verb. And this is very important. So you must have your subject term, your predicate term, your copula, a linking verb that joins the subject, and then your quantifier, A, E, I, O. Your quantifier is your A, universal affirmative, E, universal negative, I, particular affirmative, and O, particular negative. And this expresses the quantity or number of categorical statement, all, no, some. Categorical statements can also vary in quality, being either affirmative or negative. An affirmative categorical statement affirms that one class is entirely or partly included in another. All mice are rodents. Some mice like cheese. So this would be an A statement, universal affirmative. All mice are part of the class of rodents. The next one is an I statement. Some mice are of the class that like cheese. A negative categorical statement denies that one class is entirely or partly included in another. No mouse can fly. All mice which are mice cannot fly. That's an E statement, universal and negative. And then some mice do not get caught. That's an I statement. Some mice who are of the class of mice that do not get caught. Some mice who are of the class of mice do not get caught. Many categorical statements do not fit any of the standard forms, but they should, so that we can more easily address their validity. The pattern of all standard form categorical statements is quantifier, subject term, copula, predicate term. So quantifier, A, E, I, O, subject term, copula, that's your joining, R is, and then your predicate term. So terms, when translating statements, number one, we must identify the terms, and we need to, again, distinguish the subject term from the predicate term. We need to reword the terms so they name classes if necessary. And that's very important. So we might have to reword the terms to ensure that they name a class if that's necessary. And then we need to put the subject, the predicate terms, in the standard order. So here's some translations, and you're going to need to know this for your exam because you're going to want to translate into standard form. You're going to want to translate some of the statements into standard form for categorical logic. All dogs are loyal. So we need to add then the class. And the class is quite simply, all dogs are loyal animals. So all dogs, universal affirmative, are part of the class of loyal animals. Some guys have all the luck. Some guys are people who have all the luck. Some guys are part of the class of people who have all the luck. And then beyond the mountains stood the redwood trees. This one's not as easily identifiable, and so we change it to say the redwood trees stood beyond the mountains. Excuse me. All right, so we're back, and as far as I can tell, we're recording. It seems all right. I hope this is working well. We'll check it at the end. So we're back into translating into standard form, and the words only and only if precede the predicate term in an A statement. So only palm readers are wise advisors, or we could say all wise advisors are only if something is a music file. Is it a WAV file? And so we would translate that as all WAV files are music files. So do you see how the word only becomes an A statement, a universal affirmative? Only palm readers are wise advisors. And we want to change that. We want to translate that into standard form. And so we translate it, all wise advisors are palm readers. You see that here? And again, this idea of only if something is a music file is it a WAV file, and so we would translate that into standard form as a universal affirmative, or an A statement as all WAV files are music files. All right. So if we continue on, we can also see the words the only precede the subject term in an A statement. Hamburgers are the only real junk food. So again, this is a universal affirmative, because we would say all real junk food is hamburgers. And again, this idea of the only crimes prosecuted are murders, all prosecuted crimes are murders. Moving on then, if we look at singular statements, they're asserting something about a single person or thing, including objects, places, and times. We want to think of each subject term as naming a class in which there's just one member. So we could look at this as Jamie Foxx is an actor, and we would say all persons identical to Jamie Foxx are actors. So this is a singular statement asserting something about actors and Jamie Foxx. We know that Jamie Foxx is an actor. To translate it into standard form as a universal statement, we would say all persons identical to Jamie Foxx are actors. And so that then would give us our translation into standard form. We also then want to look at our quantifiers. Some quantifiers may be in a non-standard form and some may be unexpressed. Every hockey player is an athlete, and so to translate that into standard form, again, we want the A statement, the universal affirmative. We would translate it as all hockey players are athletes. All hockey players, or anyone who is a hockey player, is part of the class of athletes. And so we can give the universal affirmative in this case, all hockey players are athletes. And then again, this one, whoever is an artist is a genius. Again, this is a universal affirmative stating that anyone who's an artist is a genius. How do we translate most, a few, several, almost all, and similar terms? We translate them as particular affirmatives or I statements, some. So when unexpressed quantifiers are not obvious, assume the one that you think would make the statement most likely to be true. Trent University students are radicals. Is that true of all Trent University students? Well, we would be hard-pressed to be able to prove that all Trent University students are radicals. And so we want to then apply the particular affirmative and translate it into standard form by saying some Trent University students are radicals. Some, not all. All right, so once we have looked at this idea of A, universal affirmative, E, universal negative, I, particular affirmative, and O, particular negative, we then want to diagram, and that's where we use these Venn diagrams that become tremendously helpful to us. So here we have an I statement, particular affirmative, some S are P. So we'll notice the circle on the left. If you look at this circle here, that's the class of S. And if you look at this circle on the right here, it's a circle, that's the class of P. And so the area where the circles overlap, those highlight or show us that both S and P members are present. And so we put an X where those circles overlap to show that at least one S member is a P member. So some cars are hybrids. Now remember, this is an I statement, a particular affirmative. It's not a universal affirmative. It's not saying that all cars are hybrids. It's saying that some cars. So where the circles overlap, the P is hybrids, the S is cars. Where cars and hybrids overlap, you have at least one car that is a hybrid. Of course, you could have a number more, but we are very aware that not all cars are hybrids. So we indicate the particular affirmative, the I statement, with the X in the middle. If we want to do the O statement, and that is the particular negative, then we want the X outside of the circle to show that some S are not part of P. Some cars are not hybrid. At least one car is not hybrid. And so you can see that because we have here this X in the circle showing that we have a car or some cars that are not hybrid. Some that are, but at least one that is not. So X is in the S circle, but outside the P circle. This shows that at least one S is not P. Some S are not P. Some cars are not hybrid. Now remember, if we were doing it as a particular affirmative, some cars are hybrid, we would put the X then back in the circle here, where S and P intersect, to show that at least some S are P. That's an interesting one, and I was reviewing it again last night just to make sure that I really had this diagram clear in my mind and how I could explain it to you. And it's really quite simple once you grasp it. It's very, very helpful. But this is a universal affirmative. All wombats are marsupials. All wombats are marsupials. And so we then shade the diagram in this way. And so I like the statement: the part of the diagram where the S circle does not overlap the P circle is shaded, showing that the area is empty. In other words, there are no wombats who are not marsupials. It's not that X in the middle, some wombats are marsupials. It's not X in the S, some wombats are not marsupials. What we want to show is that any wombat falls into the class of marsupials. So the S then is shaded to show that there is no wombat that is not a marsupial. So that area is empty. Ooh, excuse me. Oh, I need my coffee. Sorry about that. Apologize. E statement is a universal negative. There are no S that are P. No wombats are marsupials, or in this case, no mice are reptiles. S being mice, P being reptiles, and we shade this in fully to show that there is no overlap, that there is nowhere where mice are reptiles. Okay? So remember, if we said some mice are reptiles, there'd be an X here. If we said no mice some mice are not reptiles, we put the X in the S. But because we're saying no mice are reptiles, we shade this to show that there is no overlap between S and P. So three steps to diagram a categorical statement. Number one, draw two overlapping circles, each one representing a term in the statement. So the first thing you want to do is you want to draw two overlapping circles. You want to label the circles with terms. So this is S and this is P. So I've labeled it now. You can see S and P. And then I want to shade an area of the circle to show that an area is empty, or insert an X to show that at least one member of a class is also a member of another class. So I'm going to show here that all university students, some university students have reading week. Can you see that? Some university students, S being university students and P being reading week, some university students are of the class of reading week, right? And so we draw those circles and then we place our X, or we shade it. I could shade this in to say that no university students, let me shade it in quick and I'll show you. No university students are part of reading week, right? Universal negative. All right, so Venn diagrams can come in handy when you want to know whether two categorical statements are equivalent. If the diagrams for the statements are identical, then the statements are equivalent. For example, do the following statements say the same thing? No S are P and no P are S. If you diagram both statements, the answer will be immediately apparent. The diagrams are identical. The statements are equivalent. No S or P, no P or S, right? No cats or dogs, no dogs or cats. Identical statements. All right, so moving on then. Now we come to categorical syllogism. A syllogism is a deductive argument made up of three statements, two premises and a conclusion. A categorical syllogism is one consisting of three categorical statements, A, E, I, or O, universal affirmative, universal negative, particular affirmative, or particular negative, interlinked in a specific way. We refer to the predicate term in the conclusion as the predicate term for the whole argument. Now that's really important. The predicate term in the conclusion is the predicate term for the whole argument. The subject term in the conclusion is treated as the subject term for the whole argument. The other term, which appears once in each premise but not in the conclusion, is referred to as the middle term. Now, you'll see how this becomes clear. So, if we symbolize it with letters, we can say all M are P, all S are M, therefore all S are P, where M is the middle term, P is the predicate term, and S is the subject term. For an example, all elected officials are civil servants. All politicians are elected officials. Therefore, all politicians are civil servants. Do you see how this ties together? All right, so if you go back here, all M are P, all S are M, therefore all S are P, where M is the middle term, P is the predicate term, and S is the subject term. So S is politicians, P is civil servants, and M is the middle term for elected officials. And we'll diagram this in a moment to show you how it works. A valid categorical syllogism is such that if its premises are true, its conclusion must be true. So we call that a what kind of argument? Think about it. That is, if the premises are true, the conclusion cannot possibly be false. If the premises are true, the conclusion must be true. We can check the validity of categorical syllogisms using the Venn diagram method. So, since a categorical syllogism has three terms, we need three overlapping circles. Remember, in our previous diagramming of a categorical statements, we had an S and a P. Now, we're looking at categorical syllogisms, we have an S, an M, and a P, a subject, a predicate, and a middle term. So the top circle is our middle term, our bottom left circle is our subject term, and of course our bottom right circle is our predicate term. The lower circles together represent the conclusion, right? Since they stand for the relationship between S and P. So 5 steps to checking validity with Venn diagrams. Number 1, draw 3 overlapping circles, each circle representing a term in the syllogism. The 2 circles representing the subject and predicate terms should be placed on the bottom. Label the circles with terms. Diagram the first premise. Diagram universal premises first. When diagramming a particular premise, if it's unclear where to place an X in a circle section, place it on the dividing line between subsections. Then diagram the second premise. Check to see if the diagram represents what is asserted in the conclusion. If so, the argument is valid. If not, it's invalid. And I'll show you this now in a diagram. We never diagram the conclusion because in a deductive argument, the premises imply the conclusion. Once we diagram the premises, the resulting combined diagram is already supposed to represent the information in the conclusion. An example, all barbers are singers. Some Italians are singers. Therefore, some Italians are barbers. All right? Now, this is a complex categorical syllogism. Remember, our S is our Italians, our subject. Our P, our predicate, is our barber. And our middle is our singers. Right? Notice where the X is placed. It's placed on this outer line here. So we know, first of all, that all barbers are singers. So we know that all barbers are singers. So we shade in the barbers to show that there are no barbers who are not singers. Do you see that? We've shaded this in to show that there are no barbers who are not singers, because we've told you all barbers are singers. So all barbers sing. So we shade this in to show that there are no barbers who are not singers. But notice, the shading overlaps here because we want to show that not all Italians are barbers, okay? Or not all barbers are Italians. My mistake, not all barbers are Italians. Then we want to show that some Italians are singers, and so we place the X here, if you can see it here, in the middle of the 3 circles, to show that some Italians are singers, and if the premises are true, then the conclusion must be true. And if we say that all barbers are singers and some Italians are singers, and we know that therefore it's a logical deduction that there are some Italians who are barbers because some Italians are singers, and all barbers are singers, and Italy must have at least a few barbers, and those barbers, because all barbers are singers, would sing. And so you would diagram it in this way. All right, hope that makes sense. Think it through, just play around with the diagram a bit and see what you come up with. Checking validity without Venn diagrams. A valid categorical syllogism must possess precisely 3 terms. A valid categorical syllogism cannot have 2 negative premises. A valid categorical syllogism with at least 1 negative premise must have a negative conclusion. If a categorical syllogism breaks even one of these rules, it is invalid. On the other hand, a categorical syllogism that does not violate any of these rules is not necessarily valid. It may be defective for other reasons. So if a categorical syllogism breaks one of these rules, it is invalid. Okay? It must possess precisely 3 terms. It must have cannot have 2 negative premises. It cannot have 2 negative premises. And it must have at least, if it has a negative premise, must have a negative conclusion. All right. So every categorical statement has a subject term and a predicate term. There are 4 standard forms of categorical statements: universal affirmative, universal negative, particular affirmative, and particular negative. Categorical statements must be translated into standard form. This involves identifying the terms, ensuring that they designate classes, and determining the quantifiers. Venn diagrams help us visualize categorical statements. A categorical syllogism is an argument consisting of 3 categorical statements, 2 categorical premises, and a categorical conclusion. A syllogism consists of a subject term, which appears in one premise and the conclusion, a predicate term, which appears in the other premise and the conclusion, and a middle term, which appears once in each premise. The easiest way to check the validity of a categorical syllogism is to draw a 3-circle Venn diagram. If the diagram reflects what is asserted in the conclusion, the argument is valid. If the diagram does not reflect what is asserted in the conclusion, the argument then is invalid. All right, so I hope that that's been helpful to you. Please read, obviously, this chapter in your textbook and play around with some of the Venn diagrams. Try to diagram. I think actually you have an exercise. I'll have to check that takes you through that. And please email me any questions. Thanks so much.